So this is problem C1 of division 2 from the round 1101. And basically what it's asking is that you're given a string s, and you're also given three integers n, x, and s. N is the length of the string that you're given, and x is the amount of tables, and s is the amount of seats per each table. And the question is asking is that you have a list of 5 friends, each represented with a string of their personality types. E means that they're an extrovert, I means they're an introvert, and A means they're an ambivert. And if it's and you want to put them into specific tables, and each table there's X tables, and each table has S seats. And you want to have the most amount of people in your party. And the way you do this is you first take the first value, your current index inside of the string. So right now it's E, which is an extrovert. And extroverts, they can sit anywhere, but they have to be seated in a place, in a table where there's already somebody. So since right now the first value is an extrovert and there's nobody in the two seats, then we can't seat him. So now we're looking at the introvert, and the introvert can be seated. The introvert has to be seated somewhere where there's no, in a table where there's no other people sitting. So this introvert can sit in either of these tables. So let's just put the introvert here. And now we're at the current value ambivert. And the ambivert is a mix between the introvert and extrovert. And the ambivert can sit anywhere. The ambivert can sit in an empty table and also a table with people already in it. So we can place the ambivert right here. And for another introvert, we can place the introvert here. And then for the last extrovert, we can put the extrovert here. And then we'll have 4 people seated. So the first thing we notice is that n is smaller than or equal to 3000, and that's a pretty small number, and that entails that we can use an algorithm of around O of n squared time. And then we realize that the placement of an extrovert does not affect the placement, your ability to place another introvert. Because an extrovert, to be placed, you need an introvert or an ambivert already inside of the table. And after you place the extrovert inside of the table with the introvert, then you can't place more introverts into the table anyways. So the placement of extroverts only affects the placement of ambiverts, and it's kind of the same way or same the other way around, where the placement of introverts doesn't affect your placement of extroverts too, and your placement of introverts are only affected by your placement of ambiverts. So now what we can think of is that we can place every extrovert and introvert as much as we can, but the question is basically asking is, for the ambiverts, do we choose to treat them as introverts or extroverts? So do we choose A to be an E, or to be an do we choose A to be an introvert or an extrovert? And my solution kind of takes advantage of our ability to do O of n squared. And what I do is I simulate through the answer, so in the formula, so that the first I A's, the first I A, this I is different from this I. I means from 1 to n. The if I simulate the answer for the first 1 to first I, which is a value from 1 to n, A's, and treat them as introverts, and the rest n minus I are treated as extroverts. And then I simulate through this, and I find the maximum answer. So for example, EIAIE, if I treated this our first and only ambivert as a introvert, my answer would be I can't place this, I can place this, I can place this, so that's 2. I can't place this, and I can place this, and this is 3. And then I simulate for the next one, but I treat A as an extrovert, and if I treat A as an extrovert, I get 4. So now we can look at my code for this problem. And what I do is first I insert in all the values, and I keep a value that contains the number of A's that we have. And from there, I create a for loop that goes from 0 to A. And what that does is it does my formula, sorry, the correct values from 0 to N. And for each loop, the way I calculated it is I create a variable called available, which means the amount of A's that we use as introverts. And then I create the values, the current answer, the number of seats, and the number of tables we currently have. And then I simulate through the string if the current value is an extrovert and the amount of seats that are available currently are bigger than 0, then I assign it and then I add to my answer and I subtract. And if the current value is an introvert and the amount of tables currently, like there's more empty tables, I take that empty table, I add to my answer, and then I add the amount of other available seats that taking this empty table allows us to take more extroverts or ambiverts. And else in this place, I am looking at the possibility where the current index is an ambivert, and if there are more available, so right here, if it says available is bigger than 0, that means I can treat this current ambivert as an introvert. And this is what I do. I then add to the amount of tables, and I just treat this the same way as I would treat an introvert. And if available is not bigger than 0, or if the current amount of tables is not enough, I just treat the if the current of table there's no more empty tables, then I just treat the ambivert as an extrovert, and I add to my answers, and then I create I find the largest answer for each loop, and then I print out the largest answer. And that's the solution, and I'll attach the link in the description.